In this question, they say we have two resistors R1 and R2, both 5 ohms, connected in parallel. So let's just call this R1 and R2. A 4 ohms resistor is then connected in series with the parallel combination. So you have a parallel combination, and then you have a 4 ohms resistor in series with the other two. Let's just call this R3. The battery has the potential difference of 13 volts. The question is, what are the currents and voltages through each resistor? So first of all, let's just find the equivalent resistance. So we know that R1 and R2 are in parallel. So that is R12, 1 over R12 equals 1 over 5 plus 1 over 5. That is 2 over 5. So R12 is 5 over 2, which is 2.5 ohms. And then R12 is in series with R3. So when you're in series, you add the numbers. So Req for the whole circuit is R12 plus R3, which is 2.5 plus 4, which gives us 6.5 ohms. Now for the whole circuit, let's do V equals IR. So we have 13 equals I total. So I total here times Req, and Req is 6.5. So I total is 13 over 6.5, which is 2 ohms. So I total is 2 ohms. Now think about I total, and it's going in this direction, and it comes here. Remember, current is like water flowing through a pipe. It has to split into two. And then they meet up back here. So let's just call this I1 in R1 direction and I2 in R2 direction. So I1 comes back down here and I2 like that. So I2 goes through R2 like that. And then we are back to I total. So you see that R3 is getting the I total value. So R3 is getting 2A. So that is our current through R3. Now what else can we find at R3? So at R3, let's do V equals IR. So V3 is what we want to find. I3 is 2 amps that we found here. And then R3 is 4 ohms. So V3 is 2 times 4 is 8 volts. So that means R3 gets 8 volts. So R3 has a resistance of 4 ohms. The current through R3 is 2 amps, and the voltage or the potential between R3 and the ends of R3 is 8 volts. Now if you remember, in parallel, when you have things in parallel, the voltage is the same. If resistors are in series, then you have to add the voltages. Now we know that R3 is in series with R1 and 2. But the total we have is 13. So if you have a total of 13 and then R3 gets 8, how much does R1 and 2 get? So R1 and R2 each get total of 13 minus 8 volts. So that is 5 volts. So this 13, this is the total, and this is how much R3 got. So we have 5. So why do I say they each get 5 volts? So we know like the blob here, so the R2, R3 blob is getting 13 minus 8, which is 5. Now if you think back, because R1 and R2 are in parallel resistors get the same voltage. So R1 and R2 together they get 5 volts, but because R1 and R2 are in parallel, each one also get 5 volts. Now let's look at the top branch. So at R1, okay, let's do V equals IR. V for R1, so this is V1, I1 and R1. So V1 is 5 volts, I1 we don't know, R1 is 5 ohms, which gives us I1 equals 1 amps. So we have 1 amp here. Similarly, let's do R2. V equals IR. So V2 is 5, it's right here. I2 that we don't know, and R2 is 5 ohms again. So I2 also equal to 1 ohms. Now does this make sense? Well, I1 and I2 are both 1. So I1 here and I2 here are both 1 amp. If they are 1 amp, then when they add up, that must equal to the total, because that's how much it's coming to this junction. So 2 amps is coming to this junction, and 1 go to the top and 1 go to the bottom. And they are equally split 1 and 1 because the R values are the same. If the R values are not the same, they won't be 1 and 1. I want you to do this problem again with different numbers and put different values for R1 and R2. Let's say put 3 ohms and 4 ohms, something like that, and then do this problem, and you will see that the I1 and I2 are not the same value.